What if the plastics that you choose for your medical device 3 years ago is the reason you can't sell into Europe next year? Sustainability isn't a nice to have anymore. It's really becoming a market access issue. So I brought on Lucas Pianegonda, who's one of the leading experts in sustainable plastics for medical devices. He runs Gradical out of Switzerland. He studied material science at ETH Zurich, has developed material strategies and helped dozens and dozens of medtech companies figure out plastic selection, material compliance, and sustainability strategy. In this conversation, he walks through the 4 forces actually driving sustainability in medtech right now, the biggest levers you can pull without killing your margins, and how to choose the right plastic without getting burned by regulatory surprises. He also drops why there's some sustainable alternatives that really aren't what they claim to be. So if you're building medical devices, if you're thinking about materials, compliance, and sustainability, there's a ton of tangible takeaways for you in this episode. Stick around, I know you're gonna love it. Lucas, so excited to have you on the pod. We had an awesome conversation the last time we talked on your podcast. Where does this pod find you today? Where are you calling from?
Yeah, so I'm from Switzerland. I live in Bonaduz, which is in the Alps, very beautiful. And today it's very springy outside. So I'm missing a good weather today.
Yeah. Are you a big skier? Ski, snowboard?
Oh no, completely not. People like look at me as if I was an alien. If you're a Swiss person and you don't ski, it's like you're an outlier. But I have too many other hobbies, and I kind of just stopped doing skiing because the effort to reward ratio is just off. It's very expensive.
Oh, I know. It really is. You know, I feel the same way about like hunting. Like I grew up doing it a little bit, like duck hunting and stuff, but like it's especially with where I live now, like it's like a 2.5 hour drive and you're there for a long time. It's all this equipment and you got to have the lease and you got to get full. It's like the most expensive hobby. And like, also like you can go out there and do it and come back with nothing.
Yes.
You know what I'm saying?
Yes.
And I know it's fun just hanging out with the guys, whatever. But anyways, I digress. Let's get into it. So those of you that don't already know Lucas, he's a globally recognized in the sustainable plastics and medical technology space. He's founder and managing director at Gradical, Swiss consultancy group focused on medical grade plastics. So like you've done it all, I feel like material science at ETH Zurich, worked at EMS Chemie and then MedMix, working on like plastic selection, material compliance, sustainable materials. And then Gradical you founded that 2022,
yes,
right?
That's correct.
Yep, and you've helped dozens and dozens and dozens of companies with plastic selection, material compliance, material testing, sustainability strategy, whatever. And you have your Gradical podcast, which is in German, but you're starting to do episodes right in English, correct?
Yes. So I started in German. I did I think 50 episodes in German, and now I started to do it in English. We also have a YouTube, so check that out. And so as you said, I'm a material scientist by training. And my passion is helping medtech companies to select the right plastic for their application. And that from a holistic angle. So from technical, regulatory, sustainability, but also commercial aspects need to go into this. And so that's what I do.
Yeah, no, that's awesome. So I'm going to start kind of, I guess, maybe set the stage a little bit. Like I love when people niche down, right? They find their thing, and they really just focus on that. And I feel like in today's world, like you kind of got to do that. So I love the niche that you're in, sustainable medical plastics, working with whether it's, startups, emerging companies, growth companies, large cap on their material selection, becoming more sustainable, the advantages of doing that, right? Like how did you kind of find your way to this? Was this a passion? Were you 10 years old drawing with the crayons in school? Thinking about plastics, or like when did this, kind of how did this evolve over time to get you to where you are today with Gradical?
Okay, that was a really fun story. So like when I was 7, I think, like my parents used to ask me, okay, what do you want to be when you grow up? And I said, yeah, I want to be an inventor. And then my dad told me, yeah, if you're going to be an inventor, then you're going to be an engineer. So, okay, then I'm going to do that. And then he told me, but yeah, then you need to go to university. And I was like, okay, and then I'm going to do that. And he then said, but then you have to do a gymnasium, which is basically like a mix between college and high school. So we have the different system than in the US.
Yeah.
So, and then I told him, yeah, then I'm going to do that. And yeah, so I did. So
that's awesome.
I went to university, studied material science. And then with my master thesis, I got a patent for my master thesis on silicone 3D printing. So I got the inventor part out of the way when I was 25. And then I was like, okay,
that's awesome.
Cool. What do we do now? So I went into the plastic industry, worked a little bit on material selection with a polyamide manufacturer. And then I wanted to do something with project management. So I did a project management training and then went to the company that is called Medmix. And with this journey, I built a plethora of things I could do. I always had the opportunity, I had the opportunity to found a startup with invention I did at my master thesis, and I didn't take that opportunity because of personal reasons. So, namely, it was the location where the startup would have been would be a 2-hour drive from where I live. My wife had her job here. So I basically decided for my wife and against the startup. Yeah. Those are tough decisions because I really would have loved it. I love the topic, but I decided against it. And that really bugged me for a couple of years. And then in the beginning of 22, I did a writing exercise. So what do you want to do with your life? And what do you want to do with your career? And one point emerged and it was, okay, I think you should be your own boss. And then I said, okay, I'm going to found my own company. And then I'm going to figure out what I'm going to do. So I put it backwards because I realized, okay, if the great idea comes, I'm going to build it. But the great idea never comes. And it took me 5 years waiting for the great idea until I realized, okay, just start and then figure it out later. And then I did an analysis of, okay, what can you do? Material compliance, material selection, material testing, training, all that stuff. And what I found is the topics, material selection, sustainability or sustainable plastics and material compliance, those stick. Material testing didn't run at all. It's it didn't stick at all. But every project, every request I had either regulatory or sustainability as a foundational theme. So I decided that's going to be my niche because apparently there's demand for.
Yeah, that's awesome. That's awesome. So I'm going to start off with some high level questions and stuff, and then we'll kind of dig deeper. But I would say describe the movement in terms of the push to sustainable devices. And I think, maybe this is partly different in the US versus EU versus other, UMEA area, right? So I just kind of describe, what is moving in terms of sustainable medical devices.
Okay. So, just disclaimer, this is going to be a rant, but it's going to be fun. Buckle up.
Okay.
So, number one,
we should start with the word sustainability because the word sustainability has degraded into meaning just ecology. And the word sustainability, dictionary definition is something like, I'm paraphrasing, to be carried on into the future without that detriment. And that means for every aspect, it cannot be a detriment into the future. Meaning that you need to take into account the ecology, of course, we're not doing too great on that front, but you also need to account for the economy and the patient outcome. So the social aspects and for medical.
That is patient.
Does that also encapsulate kind of where this material comes from and then what happens to it after the useful life of the device it's used in is done, right?
Yes, of course, but also the patient outcome. If you use it, for example, a recycled plastic, and then this leads to an infection, that's probably not the best idea. It's not very sustainable to sacrifice patient outcome for a little bit of CO2 savings. So that is the first thing and the first statement you need to make. And then, real sustainability also needs to take into account the safety and, of course, the economics of the whole stuff. And then I think there are 4 levers. I haven't identified the 5th, but there are 4 driving forces towards what's moving medtech. So number 1 is big corporations, and also in the medical technology space and also in the pharma space. They committed to climate action via something like a SBTI, Science-Based Target Initiative. And if you analyze, you can go and analyze the 100 biggest medtech companies, and then you find that 49 have a commitment or have a verified target. And if you want to put that in dollars, it's 340 billion US dollars in turnover. That's roughly 60% of medtech, depending on what market research numbers you believe. So First point, they said they're going to reduce their CO2 footprint. So if they want to do it, the material is one of the biggest levers. Because when you look at what are actually the biggest levers, the two biggest levers that stand out is material that you purchase and energy used during your use phase. Meaning that if you have an electrical medical device, the electric power you use over the lifetime is usually 10 times higher than the CO2 you need to produce the thing. So very, very heavily on the use phase, these electronic medical devices. And then for consumables, it's the material. So that is the first lever. So companies committing to climate action. Then the second one and the third one, they interplay. They're very beautiful to see. And the second one is the customer, and the third one is the competition. So customers want devices that use less material, that generate less waste. Because if you're looking into the hospitals and healthcare professionals, those think that sustainability is a waste problem and not really a CO2 footprint problem, because the waste is what they can see. Doesn't really mean that this is correct. It's just their perspective, because they see a lot of single-use waste that is burned every day, and that they have to throw away. And why do we have to throw away so much stuff?
Yeah, and just a quick jump in, like waste management and waste removal and processing of waste, whatever. It's a huge cost for hospitals, right?
Yes.
At like a baseline, and like changing the material without changing the design of a single-use device, like may not change that, but it might, right? There's ways that it can change it. But then to the point about the customers wanting this and whatnot, like at least in the US, I know that at least Premier and I think the other GPOs, the other big ones, there's like kind of three, I think, that really matter in terms of market share. But like they'll have, when they do their solicitations, they'll have like, we'll just call it like general surgery category. And there's just like a bunch of different devices and products and things they're doing solicitations and kind of getting RFPs for or whatever. But then they had a different and specific one that was just around like general surgery sustainable, right? So if it's like a smaller pool, there's like almost lower competition in a sense, because like they're self-selecting and saying you can only apply for, submit your RFP under this guise if you meet like these certain sustainability requirements. So like that, I think that in terms of the flow of materials, like I'm sure there are hospitals that are, wanting it and asking for it, but a lot of the supply flow for especially a lot of the consumables and disposables is going to run through the GPOs. And I know that they have these like, big commitments that they're trying to make as well.
Yes. And that is, I think, that is like 1 and 2 a little bit combined, because like your distributor is kind of your customer, but it's also a big corporation having their own commitments. Then as soon as your competition has something on the market, FOMO sets in. So like everybody has fear of missing out. So shit, my competition has something on the market. I need to do that too. And it's going to take you 2-3 years until you get something to the market. So you need to start, the pressure really starts to increase that. And not only does your pressure from inside increase because, oh my God, the competition is doing something, but also the customer will tell you, okay, hey, see, it's possible. It's like, those guys are doing it. Why aren't you doing it? Like, okay, yeah, we're on it, but we're not right there yet. So it's probably a bad idea to not have something at least in the drawer, just in case your competition comes out with something.
Yeah. And is the fourth the FOMO, or what's the fourth lever? Then I got some next questions.
The fourth is regulations. So the fourth is regulations, and those that there is, I think, so 1, 2, and 3 apply worldwide, and I think regulations is very heavily on Europe, because Europe has decided that there's going to be European Green Deal, and we're going to make our economy as green as possible. And there are a bunch of regulations coming up. So PPWR, packaging and packaging waste regulation, is like one of them. And Medtech companies think they have an exemption. They have an exemption for recycling material use, and so mandatory recycling material content and minimum recyclability. So they get exemptions for that, but everything else they need to do. Mm-hmm. So they're not really aware of that. And then there's other regulations coming up. Not only that you need to, at a certain size of a company, report on sustainability, but also that in the future, there will be eco-design guidelines or eco-design requirements that are regulatory requirements for medical devices.
Gotcha. Right. Okay. So those are the 4 levers that are kind of moving things in the sustainability direction. Yes. Are there any specific device categories or device types, or I don't want to, like, maybe discipline, but also like more specifically, like any verticals like, electrophysiology or, catheter or like, disposable X or Y that you're saying are moving the fastest towards sustainability, and like, why is that?
Yeah, so there's certainly packaging, and packaging is across the board. So I would say that isn't really a discipline that's like across the board is packaging. That's number one. And then it's ophthalmology is among the top. Ophthalmology is due to the cataract surgery being the most prevalent surgery on the planet. It's like 30 million.
Mm-hmm.
And I don't know who told me this, but it's like about to double like in the next 10 years.
Mm-hmm.
And that produces a lot of single-use waste. And very rare, you can run the theme across. Like if there's visible waste, a lot of visible waste, there's a movement towards sustainability.
Mm-hmm.
Then there's endoscopy. It's like I think endoscopy is a little also due to one of the market leaders in single-use endoscopy being Ambu, which is the complete poster child for sustainability in Medtech. So they do it all. They do they co-design, they do sustainable plastics. They have it embedded in their strategy. I think there's like really the FOMO kicking in. Then lab consumables, of course, because you use a lot of single-use plastics. Then there's auto-injectors, also a little bit due to the GLP-1 revolution.
Yep.
And in the end, it's, I think, general surgical devices. So anything that is a single-use surgical device, may be staplers or whatever, there you have the push. It's like if it's remanufacturable, so just steel that you can just throw into a steam sterilizer, that's not too much under pressure. But like these complex electronic devices, like a stapler with a drive and everything in there. So I think those kinds of devices are the ones that are moving the fastest.
Yeah. And like, with like Ambu, you mentioned it was like a big part of their strategy, right? So like, obviously, if you're a company that like really cares about sustainability and like you're making it part of your like core thesis, core focus, right? It's both on the materials you use for the device, like you said, the materials of the packaging, but also like how they're packaged, right? Like the configurations and the, like, are you using double barrier this and then another pouch and then another box and then another box, right, to get one thing to a customer? Or are you going more minimal and trying to reduce that footprint? But then also like the reuse and multi-use and kind of reusability of the devices themselves, right? So like specifically I want to ask about, because like in the orthopedic world, right, like there's a lot of pressure from, there's kind of like push and pull pressures around, sterile processing departments are small and overwhelmed, right? And then so single-use instruments, right? So especially for ASCs, more people are wanting to use those, right? But like, how are you saying across, different, geographic landscapes and things like that, like interplay between material selection and whether it's multi-use or fully reusable or like, basically use life, whether it's hybrid where it's like you have a disposable, but the rest of it's reusable. Like, how are you seeing that kind of design considerations merge and blend with the sustainability considerations on materials?
Yeah. So first of all, what we need to think of is that single use has a bunch of advantages in terms of convenience and I'd say workflow, convenience, and also at least perceived patient safety. Because it's single use and it's always sterile. And if you have a reprocessing unit, it's like they might make issues or might make mistakes, and then you're not sterile, and then the patient has a problem. So that's like the first one. The second one is like you need to take into account the economic aspects. So patient outcome, of course, could be detrimental, but also like the social aspects. You can do like a surgery more with a single use device because it's just more convenient. And then the second one is the economics. If I have, for example, let's take endoscopes because we run that case study through in our podcast with Ambu. If you have a multi-use endoscope that costs you this quite considerable investment, like 15, 20K can be in this direction. And then you have to have 10 of those because you want to do 10 patients a day. So that is an upfront capital investment. Yeah, big cost, and then like if one breaks, like you can also only do 9 a day because it doesn't come back sterile, for example. So there's also workflow implications here. And then the sustainability implications is I can make a single-use endoscope out of much environmentally less taxing and less costly materials because I don't have to reprocess them. Because if I have to reprocess them, it needs to be a lot more durable because it needs to, and your regulatory requirements say you have to test and make sure that your devices will be safe and effective no matter at what cycle you are. If you say to a hospital, you can use this 50 times, you need to make sure that it's as good at cycle 50 than it is at cycle 1. So therefore, you need to use higher value materials. And that leads to the conclusion that usually for very simple and easy to manufacture devices, such as I would say syringes or intraocular lens injectors, like the CO2 footprint definitely will be better, and the cost implications will be better for these simple devices if you make them single use. And the more complex you go, the more multi-use starts to make sense. And the heavier material burden you have, so to say. So if you start to use rare earths, if you start to use noble metals and stuff like that, then it starts to make sense. So I make this funny example. Nobody uses a single-use CT. Nobody does that because it's just like, it doesn't make sense. Like, but nobody reuses a syringe that you've used to pull blood.
Yeah, no, I'm with you. That makes sense. Yeah, and I know this is kind of like tangential, but it's still within the same sustainability track though. Like there's a group called ProPlate. Shout out to ProPlate, Ross, he's the man. They do vacuum deposition and like rare earth metal coatings on balloons, non-compliant balloons, different types of things. And they've got some like incredibly advanced, chemistry processes that they, deploy to be able to do this, right? But as you probably know better than I do, like a lot of these processes will be like, there's a lot of baths and you're doing these chemical reactions and things like in a, basically in a water tank, if you will. Right. And it's probably not water. I'm messing that part up, but like it starts as water's a big component of it, whatever. But anyways, I was talking to Ross at MD&M when we were out there for the conference, and he was saying that they basically set up I'm going to butcher this, but in essence, like a waste removal and water recycling system to where, they're running through a process for, say they're going to put plating for an electrophysiology balloon catheter, and they're going to do like, 4,000 of them or whatever, right? That takes a lot of water, right? So they've got a system where they're like cycling that back out. And I think he said it cut their water usage by like 98%. And here's the other kicker that I thought was really interesting. He was like, the water that we get back from this system and reuse is cleaner and better than the water that we get from the tap originally. You know what I'm saying? To feed into this, right? And then I was kind of talking to him and just spitballing, and we were discussing like, okay, so, I don't know if everywhere's like this, but like we get all this change in the seasons, and sometimes like our lake or whatever, where our freshwater source is like, principally pulled from, like you can almost tell like when the lake turns, you know what I mean? Like there's like, algae movement or whatever. And like, you can like almost taste it a little bit, and like the hardness of water is different, right? So there's all these things that I'm like, in my head talking to Ross, I was like, maybe is there a more reliability and repeatability when you have recycled water, because exactly every single time the chemical composition and the makeup, the presence of minerals and any other like even small, elements in it. So I just thought that was interesting. I don't know if that like kind of plays into anything, or if you have any thoughts on that.
I mean, what is very interesting here is that you brought up water, because usually people start to, and if they start out with the sustainability Germany, they always will start with the CO2 because of climate change. However, the planet doesn't only contain, or that isn't only impacted by climate, it's also impacted by water use, by land use, by biodiversity. And if you want to measure all of this, you need to do something that is called like an LCA, and you do something that is called a life cycle impact assessment. So depending on where you live on the planet, certain uses of resources will be different. So CO2 is the same everywhere, but if you use water in like the Great Lake area or in Switzerland, like there's plenty of water. But if you use it in like the sub-Saharan desert or in like Arizona, like, yeah, there's not too much water there. So the local impact on your environment using a resource can be vastly different depending on where you are. Also, that the same goes with land use. So, and this is always a discussion, like what is the exact like KPI we should measure for sustainable? Because it's like sustainable is not even, I'd say it's not precise enough. It's like
subjective.
Yes.
Right.
So you need to have these different impact categories, like CO2 impact or land use or water use, and then you are talking about much more precise ways. What was also interesting is that this was what Ambu told me, is if you reprocess, you also use a lot of water, you use a lot of chemicals, and by the way, you also generate a bunch of waste, because like gloves and drapes and whatever you need to clean. And they found that when they did the LCAs or researched LCAs, like 4 out of 5 said it's single use is better for their endoscopes. Of course, they're a single use company; they're gonna tell that. So just as a disclaimer up front, but I think they wouldn't do it because I think they wouldn't do it like this if they thought it was better in multi-use.
Yeah, no, that's interesting. Yeah. And quick aside on the water thing, like I think we need to outlaw almond milk. Like almond milk's not that good anyway, but if you look at the data on how much water that almond milk uses, it's absurd. And where almonds are grown in the United States, which is in California, which like has water issues already. So like I'm on team ban almond milk. Like eat your almonds all you want, but like if you want other milks, there's oat milk, there's whatever, but like it's too much. Anyways, but okay, question here. And this is more just want to get your thoughts on really. Like I've built devices that were single use, design and built, devices that are fully multi-use. Obviously, like everything has a lifespan, right? So you can kind of set that whatever. But like I know there's countries like in India, right? Like even if we ship them a single use device, like depending on the device, they're like, hey, like this is probably going to get reused, 2 or 3 times, right? And they're going to reprocess or re-sterilize it, whatever. As long as there's not like real, like a syringe, right? But like there's a high number of things where you could like feasibly reuse it 2 or 3 times, kind of taking aside the sterile processing concern. How are you viewing from a commercial and revenue and business model perspective? Like, what do you think the answer is for those pressures on development teams, but also like executive and management teams, right? Saying like, hey, like, are we going to make this thing single use? Or like, if we're going to make it multi-use, they may do fatigue testing and it's good for 50 cycles. And they're like, there's not the business model, let's make it 12. Like Da Vinci's robot arms, I think there's like elements of those that like you can only reuse like 12 times. You know what I'm saying? I would almost be certain you can use those more than 12 times, right? And like, yeah, safety factor, but like, I bet you they've done testing, right? And I'm not singling out Da Vinci, but like, I bet you there's a lot of companies where it's like, we did fatigue testing, you can use this 100 times before the failure rate approaches like, 0.01% or 0.1%, but we're going to set it at 15 uses because that's better for our business model. Like, how do you think about or square those commercial pressures that are ultimately informing the design and development team in a lot of organizations?
Yeah, so
I think you don't have to go.
That's a multi-layered question. You think you don't have to go to India to see single-use devices being reprocessed, because in Germany there's a company that is called Vanguard, and they do reprocessing or remanufacturing in that case of single-use medical devices. So they gather them at the hospital, they clean them, they test them, they re-sterilize them, and then it's their device. So they are the legal manufacturer, although like there is another name on there. Legally, this is fun because they get sued 3 times a year. And I think they had to redo the MDR certification like 3 times. I don't want to be quoted on that, but I think they had to do it multiple times because the notified body didn't know what to do with them because they're so out of line. I don't say that in a bad way, but they're like doing something they wouldn't have imagined. And like with the updated MDR, I think it's going towards a like unified European market for reprocessing of single-use devices, so it will be possible. And I think also in the US, they remanufacture some of the stuff. It's not unheard of. And then the business model question is like, of course, the original manufacturer of these devices is going to have something against reprocessing. Number one is like, there's my name printed on it, and I don't like people selling my devices with my name on, and like they have a point there. But secondly, I don't sell devices if they sell a secondary device. So if they sell a reused or like a remanufactured device, I'm not going to sell my initial device or my new device. So I think, funnily enough, surgical devices, sometimes I compare them to power tools because like, this stapler is not too different from a drilling machine. I don't have to be very imaginative to say this is a power tool. And if this was a power tool, I would have used this for years and not just for this one instant this afternoon.
Yeah.
And there's a drilling machine company very close to where I live. It's called Hilti. It's like the power tool company.
Yeah.
And what they have as a business model is they don't sell drilling machines. They sell the ability to make a hole in a wall. So like you have a subscription and you get your Hilti, and then like if it breaks, they just like next day you get a new. And so it's like a subscription model. And I think this is a lot of potential, because you decouple the physical content or the physical production of your device from your revenue, so to say. So I just always make sure that you have a functioning device. And then my incentive is to keep your device as easy in maintenance, as cost effective as possible, and as sustainable as possible. And I don't have to like sell you a new device every time. And I think a bunch of issues with this is that, like, if you have a stapler, like, there's a mess on the tip. It's like you have all kinds of bodily fluids there that you do not want there, and it's extremely difficult to clean that. So you don't want that. So what comes in here could be something that you call the hybrid use device, and I really like this concept. You have a durable part and then a consumable attached to it that is single use and that is always sterile. And then you have like basically the power tool where all the batteries and the rare earths and of course also the intelligence. Nowadays our devices will have AI in them, and you don't throw them away. So you keep that, and you have the smaller part that is single use. And I think Medtronic has something on the market already. There's a hybrid use stapler. So that is not theory. So you could have a subscription model or an outcome as a service or a device as a service. Yeah. Or you can combine that also with a hybrid use device, because like razor and blade really works well. Like that business model is
it's a great model. I mean, I think too, like, you know, the U.S. healthcare system is just like such a mess, you know, and it's so driven by, you know, the Medicare, Medicaid reimbursement and the private pay reimbursement. And those things are static, you know, static in the sense they're kind of like difficult to move, shift in big, like, you know, fundamental ways. But like this is all reminding me of like a conversation I had, you know, on 3D printed like patient specific implants, right? And how the data's pretty clear that they have better outcomes. They are, I think, like in a lot of ways, like more sustainable, or more, at least more like they're efficient to manufacture, right? You're adding up the material that you need for the most part, and like that's the device, versus like I'm starting with this big block and I'm just whittling it down to what I need, you know, machining. But I think the thought there, you know, what our conversation and like why it's relevant here is that like the largest companies, right, that would be adopters, acquirers of these like 3D printed patient specific implants, right? Like they have so much sunk cost in the financial model around their current stuff. They have tens, hundreds of millions, maybe probably on aggregate billions and billions of dollars of inventory of these things and these long-term relationships. And so like, you know, the conversation I was having around that was just like those are such monumental pressures that are basically thwarting the uptake and adoption of like, you know, patient specific implants. And this was specifically, I think, hips and knees. But I think the same could be said for this, like, okay, well, what about a hybrid use? Or what about this, right? Like a more, you know, long-term multi-use, like until there are structural incentives around the reimbursement or around hospitals that are hospital purchasing. If you're over a certain threshold, you get like a bump in your CMS reimbursement for everything, you know, like I feel like we need that in the United States for there to be like large scale coordinated movement towards sustainability in design, sustainability in materials, sustainability right across the board. I don't know if like that's any thoughts from you, but that's just like those are the things, honestly, like the structural barriers, right, to a more sustainable future in terms of the way devices are designed and produced.
That's very good advice. If you have employees, children, or any other people that you wanna make do something. So if you want someone to do something, reward them for it. So if you're not rewarded for doing something, you will not do it.
It's either carrot or stick, right? That's how people operate.
Yes,
you know what I mean?
Yes. And funnily enough, it's like carrot works as well as stick. It's like, and both also work. So the incentives are crucial. If you don't have incentives aligned, and nobody will pay for your device, and by the way, that's just also true for your material, then it's not going to happen. It's like the same thing is happening with like sustainable plastics. Like, of course, like they have scale issue against the fossil plastics. Fossil plastics have been around for like roughly 100 years-ish. and they have been optimized in terms of scale, in terms of operations, in terms of processes to be very efficient. And they are, and that's it's a miracle that they are so efficient. Then now you have different feedstocks that do not have this scale advantage, like bio-based or recycled feedstocks. And there's like, we can go into all of the details on what the pros and cons of those are, but you'll have a certain premium at this point. And now the question is like, okay, who's gonna pay it? Who's gonna do it? Do you just like do a medical device and like push it onto the customer? Is that how you're going to do that? Well, probably not, because also healthcare systems are also stretched in terms of cost. And then how are you going to do it? How are you gonna make a business case out of sustainability? And this is like, it's not very easy to do so. But I think like my 5 cents on this is going to be, if cost and quality is on par, sustainability will win the race. It's like people instinctively know it's a good thing. And it's also designed to, if you really go with the trinity, the patient outcome, the cost, and the ecology, good for the planet, people instinctively know that this is for a good thing. And you just need to remove all the barriers. And the barrier can be the cost, and the barrier can be like the performance. But funnily enough, if you do these eco design principles properly, if you not just switch the material, but design it properly, you can like 20 years ago, it was called product optimization, and you can also bring out a lot of the costs.
Yeah. And in my view, like, I think the technology and, you know, the scale of more sustainable solutions and like the ability to design and have these business models that will work. Like, I don't honestly even think that those are the prevailing headwinds. You know, I think it is literally more the entrenchment of the current model, and then the reimbursement and kind of the legacy model, both on what they're currently doing and then like the reimbursement side. But we've got like 10 minutes. I want to like get through some other questions. So this is like a bit rapid fire here. So just walk me through, if you could quickly, like, what are these sustainable alternatives to like virgin plastics, right? Like how do you group those? How do you think about those?
So let's say we have a plastic that I'm using for my medical device. It's like, I would run it through the following alternatives. I mean, I have a framework on how to like do all of this. I have a complete.
And the next question is like, how do you help companies figure this out? So it's coming.
Number one is, okay, let's do it. Let's do it together. Number one is you need to know what your stuff needs to be able to do. So the requirements, the technical requirements, like how strong does it have to be? How stiff does it have to be? What color does it have to be? Etc. So you need to know your technical requirements. You need to know your regulatory requirements. You need to know everything that you want to do in terms of processing. So injection molding, laser printing, whatever.
Can I ask real quick on that? Because I feel like sometimes people, like, I know you're going a high level over this, so I'll go quick. But like, I feel like sometimes people are like, oh, well, I need it to be a plastic, and I need it to be hard, and I need it to be blue or whatever, right? But like, there are so many layers beneath that, right? Of like, okay, well, what coefficient of friction? Like, what's the tensile modulus? How lubricious is it? What's the water contact angle you need, right? Like I guess the question here is like, do you find that people, like, when you're getting into this process, they're like, well, I don't know what the coefficient needs to be, right? And they don't even understand like the material specifications that they truly need, right?
That is true. And I think, so that's number one. Or you go to a doctor and ask it, okay, how do you want this applicator to be? And it's like, like soft. And it's like, like soft is not a requirement. That's not a measurable thing. So you need to translate the word, okay, it's kind of soft, towards like a sure hardness that you actually can measure and you can test against either a test or on a data sheet. So yeah, of course, that is certainly the case. But I think the default is, number one is we've always used this material. So like, I have a legacy device and it works with this material, so I will take this material just because I always took this. And then the second thing is, okay, I have this device, it needs to be blue, kind of hard. I go to my manufacturer and ask, okay, what kind of plastic would you make this out of? And he's like, I have this ABS that I use for this other device, so I'll just take this because I have this laying around. So I've always used this, and I have this laying around for the manufacturer.
Yes.
Those are the default go-tos.
I've dealt with that before.
And it's not too hard to compete with that. So number one, you list out all the requirements. And of course, you run I've always used this as a reference, because that is a good candidate, because you know it works. And then what you do is you get a bunch of candidates lined up, and then according to these requirements, you try to rate them like holistically. So you rate them according to every requirement. And what can you do? Like number one is you can try to downgrade. So you have something that is called the plastic pyramid. On the bottom, you have the mass plastics, the commodities. In the middle, you have the engineering plastics. And on top, you have the high performance plastics. So good examples would be polypropylene as a commodity, then PA6 as an engineering plastic, and PEEK as a high performance plastic. And then you run across a part that is made out of PEEK. And then it's not too stressed. It's not requiring extreme stiffness. It's like, and then you ask yourself, okay, why the hell does it have to be PEEK? Because like the higher up you go, the higher your cost and the higher your CO2 footprint. It's a heuristic, but it works pretty well. So what you try to do is like you try to downgrade. So you try to come from the top of the pyramid towards like more towards the bottom, towards more volume plastic. So what you can try to do is like you try to find the downgrading option. If you can't do that, you can go for something like recycled, which has its implications. So the recycling can mean mechanical recycled, physical recycled, which is something like a dissolution technology, or a chemical recycled. And then you can also go for bio-based. Bio-based would be then just a drop-in solution that is just made from bio raw materials, same plastic. And what I would not recommend for like 99% of the cases is biodegradable plastics. Because biodegradable plastics, they just lead to a bunch of problems in shelf life and processing. I can lay out that in a little more detail, but I think you wanted to go a little faster. So those are the options that we have: recycled, bio-based, or downgraded options. Those will be saving costs.
And one thing too, like just to your point about the contract manufacturers, whatever, like you go to the manufacturer and they're just gonna like look at what they have on the shelf or whatever. Like what I have found, like unless you are working with a contract manufacturer that like based on the nature of the work that they do or whatever, just like have chemical scientists, right? Like material scientists on staff or whatever, you really cannot rely on them. And this is going to be different for every CDMO. So like, I know people are going to be like, well, we actually, yeah, sure. Like I know there's people that really do this well, but I feel like a lot of them, like when you really, really get into the weeds on materials and material options, like say you're doing overmolding and you're trying to figure out like, okay, what's the carrier molecule for the colorant that we're adding, right? Like, you know, what is the chemical compatibility for overmolding with PC or ABS or PC ABS blends, right? Like the PC ABS you're using, like what mixture of PC and ABS is like. Once you start to really like get into that, like they're going to just kind of be like looking at you to figure that out, right? And then it can be a chore in and of itself to find, right? Because like, you know this, like there's this web of material. It's like, well, Covestra, well, actually Formera gets it from Covestra and Formera sells it. And that like, they're like, when you're trying to source these materials and the feedstocks and whatever, you know, it's just this layer of distributors and resellers and all this stuff. So like, you really need to do this work early is my point. Like you need to dig into it yourself, right? With someone like you. And you need to get into it early because like some of this stuff's like 12-week lead time, right? Or some of it may have crazy minimum quantities or whatever. And like, if you're like only now when you're having some manufacturing issue or something or whatever, like trying to figure out like a material swap option, it's like a long process and it's usually you driving it. So like doing the work to figure it out and understand like, hey, am I going to get this from Avient? Am I going to get this from Covestra? Am I going to get this from DuPont? Am I going to get this from one of their resellers? What's their, all the details around that. And it takes a lot of work. And because like half the time too, like it may say like good chemical compatibility for PCABS injection molding, overmolding, right? It's like, well, what is good, right? Like, let me understand this more. You usually have to have a call with the technical engineer, technical, you know, sales engineer at the group. Anyways, I just think you got to do this on your own a lot of the times, right?
I mean, that is what we help people understand. It's like, it's a very complex landscape and it's also like, I call it a minefield. It's like, if you want to go for more sustainable, you can also, like, you will find that there are a lot of people trying to sell you material. And it's like, you can go to your materials distributor and ask them, okay, what do you have that is more sustainable? But you don't know. It's like, if you don't know, like, how can you actually decide what's actually better, and if this is the best that you can get on the market? Because that is a big advantage of having someone independent or even in-house knowledge. As painful as this is, it's like you need to build in-house knowledge about your materials. Like, what do you think? It's the same thing with biocompatibility. It's like your materials make or break your biocompatibility, and if you don't understand what's in there, yeah, you're gonna have issues. And yeah, of course, you can rely on consultants and on your suppliers or on your lab to figure it out. But in the end, it's like, who is responsible for your device? It's you.
Yeah, you need to own that knowledge.
Yes.
Yeah, you need to own that knowledge. Last question, rapid fire, and then I'll let you close it out. But like, what's one plastic that's underrated for medtech?
Oh, it's polypropylene. It's my favorite plastic. Polypropylene is my favorite plastic. It's like, if I can use polypropylene, I use polypropylene. It's cheap, it's reliable, it's very manufacturable, it's very available. It's also available in mass balanced, bio-based or chemically recycled.
Yeah.
If you can make it work with polypropylene, it should be polypropylene. The only thing it has a little lacking stiffness, so you can't make it go over 2000 megapascal without reinforcements, and reinforcements add a lot of issues. So it's like, if you can make it work with polypropylene, it should be polypropylene.
Gotcha. Okay, so we'll put your LinkedIn, we'll put the Gradical website down below, as well as like your podcast in the show notes. But just close us out here. Anything you want to share with the audience, words of wisdom, anything to plug, anything you want them to know?
Yeah. So if you have issues, come to me. Let's talk.
Yeah. Well said.
Hey.
Well said. Awesome. Lucas, thank you so much for joining the pod.
It was a pleasure.
I know I had a blast. Yeah, honestly, I learned a lot, and just thinking about sustainability in a different way after this conversation. So, and for everybody that's stuck around, tuned in for the full episode, thank you. I hope you got as much of it as I did. But Lucas, hope you have a good evening, right, from where, where you are. Have a good evening, and thanks again for coming on the pod.
Thank you very much.
All right, take care, everybody.
Bye.